Hello everyone and welcome to this video about detailing of beam and column in CSI Detail 18. So we have already created the model and designed the building in 8 tabs. So now let's do the detailing in the CSI Detail software version 18. And please do remember that CSI Detail version 20 doesn't work with ETAB version 20. So in conclusion, both the version the same version doesn't work. So here you can see I have opened CSI Detail version 18. You can check here. Okay, so now I'm gonna open the ETABs file, that is of .etab extension. So I'm gonna open this tutorial 1. So here it is checking all the files and the warning has been generated for the frame. And if you remember from the previous video, we haven't assigned for the cantilever part the beam property, so it taken it as a frame and will not be detailed. So just click on OK, and once you click on OK, our new detailing is appeared here. So just uncheck this wall and frame because we are only going to design the component beam and columns. And for the floor, we're going to go from base to story 3, and here in the edit reinforcement, this is the beam design that a value that has been extracted from the tabs. Same for the column, this is the load combination, and this is the area as per this load combination. Just click on OK. So here in the units, go on detailing units, and for the units we're going to go with metric, reverse set SI, length let's leave it millimeter, section and thickness millimeter, reverse spacing millimeter, and force we go with Newton. Rebar length let's leave it as meter, slab area square meter. We don't model or detail this slab area, so let it be. Concrete volume we're going to extract it in cubic meter, and for the rebar weight we're going to go with kilograms. For your reference you can go with ton also, but for now I'm going to go with rebar. And if you want to do any modification, click on this modify and show format, and you can modify anything extra as per your requirement. So here I'm going to just click on OK and close this dialog box. So in the preference, first select preference, and in the option, out of these 3 options, I'm gonna go with use standard preference and gonna select the IS456 2000 code and click on OK. For the concrete detailing preference, slab let it be. For the beam I'm gonna label it as B, and rest just leave it here. So the scale here, once we extract this drawing, it will generate the layout template, and the scale factor would be this one. For layout 1:50, elevation horizontal and vertical will be 1:25, and for the section it will be 115. So the column, let's go with the level prefix C, and same with the scaling. So it will export the layout, elevation and section as per this scale. You can change this as per your requirement if you need, but this is the standard one, so just let it be and click on OK and close this window box. Now let's go with concrete display preference. So here we're gonna directly go to the beam, and here if you want to use any extra, just tick this, and same for the column. So for now we're gonna just leave it as it is and click on OK. And the next important thing out of this is the rebar rules. So here let's go in the beam, and for the seismic, the one that we're gonna design, the smallest bar size we're gonna use is 12. So if you don't know what this letter denote it, just here you can see one option, click to see typical bar elevations. So just click here and you can see our is multiple span. So here you can see all the letter which denote what section of the rebar. So here you can see A, B, C. So in this way you will know which one denote which one. So for now let's go A, and this is throughout bar. I'm gonna go with minimum 16, and for the C I'm gonna go with minimum 12, for the D 12, and for the this throughout I'll go with 16 for the both E and F. For the Z I'm gonna go with 12. The largest size I'll go with 20, but believe me, you don't need this. You'll only, I think, 16 die size rebar will be enough for the beam. That is because we are only designing the simple residential building. But preferred size I'm gonna go for A is 16. Sorry, I will go with 12. For B, I'm gonna go with 16. For C, I'm gonna go with 12. For D, I'm gonna go with 16. This will be 12. This will be 12, and for Z, I'm gonna go with 16, and this one is 16. So for the stirrup, for the smallest bar size, I'm gonna go with, let's go with 10, and for the largest, I'm gonna go with 12 in all three zones, that is zone A, zone B, and zone C. And the preferred is also 12. So here, let's leave it as it is, or you can change this value to 1. The software will automatically calculate how many number of minimum extra bar we need. So for the minimum spacing for zone A and zone B, I'm gonna go with 100 mm and 100 mm minimum, and for the zone C, I'm gonna go with 150, and the maximum spacing will be 150 for both the three cases. So this I will leave it. So this also I'll leave it. This also I'll leave it. So if you want to check more, just here you can change the curtailment rule as per their code, and here you can also change the longitudinal rebar layer also. So for this, I'm gonna just leave it as it is. I'm gonna close this dialog box and go to the column, go to the seismic. For the smallest size, I'm gonna go with 12 dia bar. Largest, let's go with 20. Prefer bar size 16. And zone A, zone B, and zone C. For the ties, I'm gonna go with 10, 10 equal. And for the largest, I'm gonna go with 12. Yeah, I'm gonna prefer the bar size of 12. And for the minimum spacing in zone A, I'm gonna go with 100, zone B 100, and zone C 150. Let's go with 150 and 150. There is more option if you want to change anything here. It's like bar splice or confinement zone length. So for now, we'll leave it as it is. Click on OK. Click on OK. We don't need this bar and spandrel. Just click on OK and close the window. Default drawing, you don't have to do anything. We'll just select this concrete column and column. This is the default drawing to be generated. So click on OK. Drawing setup. You don't need this, I think, because we in most cases have already created the layout in the AutoCAD. We only need to extract this generated drawing and paste it to the AutoCAD. So just click on OK and close the dialog box. This is still the design preference and display preference. We don't need it. We are only designing the concrete section. Reverse side, you can check here the bar area for all the bar diameter size here is stated. Click on OK. Grid system visibility is G1. OK. And drawing format, here you can change the layer of the visibility of the beam and column. Click on OK. I'm not going to do anything here. So once I hit the click OK button, it will start creating the drawing with the required reinforcement. So here you can see our drawing is being created. So here in the standard detail, here you can see the list of drawing table is generated. So we won't go with the slab detail. We'll directly jump to the beam detail, and we'll see the framing of beam layout. Let's go to the study one. So here this is the framing of our beam. So this grid exactly matches with the grid that is in the ETAB and the grid that is created in the AutoCAD. So you don't have to worry that. Schedule, you can check this schedule. The concrete beam rebar. So these are the rebar detail, and this is the beam ID. So here I'm going to go in the elevation, select the story one. Let's select any beam. So here you can see in the elevation, you can see we are using two numbers of 12 dia bar, and in the bottom we are using 16 dia bar. So if you want to go detail, go to this section. Here you can see section A and B. So let's go to this section A. So this is in section A, this is section B. So here you can see only one is stated here. Now we need two. So again we have to do some changes. So we'll go with minimum with 2. And it's not, we have to unlock this one first. Go to the edit, go to the reverse review in the beam and seismic. Let's change this to 2 numbers. Click on OK. So let's see if it generated or not. So again click the restart detailing. You can see again it is written. So now check it one more time. Go to concrete beam elevation story 1 elevation. Go to section A. Now you can see 2 long throughout beam has appeared here of 16 dia, and in the top we are going to go with 2 numbers of 12 dia. This is the extra bar, this is a true bar. So here 2 number of 12 dia bar and 1 16 dia true bar. So this is the detailing of the beam. So here you can also see the framing table, beam of material. Here you can see the total volume of the beam, total rebar weight and rebar ratio. So let's go in the column. Let's see the framing. This is the framing of the column, and this is the ID of each column. So here you can see C1, C2, C3. So in the basis of this ID you can check the elevation. So let's go in this C1 elevation. So here you can see in the confinement zone we have 12 dia of stirrup, 12 dia of ties at the spacing of 100 mm, and here you can also see 12 number of 12 dia stirrup at 100 mm center, and in the middle section is 150. 12 dia at 150 mm distance. So here in the NBC 2002 code you can see the middle portion of the stirrup is at a spacing of 125 mm, that is at a spacing of 5 inch, but we have put here 6 inch. So you can change this as per your requirement. So in this way our editing of the column is shown here. You can check at section A. You can see all the bar is of 16 dia, 1 2 3 4. So here you can see the corner bar is of 16 dia and the remaining middle portion bar is of 12 dia. So for the layout of this stirrup we can change the tie bar into the diamond bar tie. So you can do that in the AutoCAD. So in here you can see section A and section B. So here in the section B it has put 14 dia bar. So you can change this one as I have shown you how to change in the beam part. So just uncheck this model and go to the detailing and go here if the detailing is reference and check go to the edit design reinforcement and go to the column, not this one, Rebar. So here in the seismic change this one. So here you can see, so you can check by just selecting here. So click on OK. For now it's grayed out because we haven't unlocked the model. So in this way you can see this and check everything, and you can make correction. So here instead of 2 numbers of 14 dia in each corner, we can go with this 16. So once everything is checked, just I'm gonna click on this drawing sheet. Here this is the number of sheet that will be generated. So just click on right click, and you can see here you have an option of exporting the drawing sheet. Click this one and you can export to anything that you want. So we're gonna choose the DXF, and here you can see the directory and just select this start export, and all your drawing will be exported in the DXF format. So I'm not gonna do it, so you can do it later. So for now I'm just gonna click on this down button. So in this way we can do the detailing of rebar in the CSI Detail version 18.2.1 software. So thank you for today, and please do subscribe my video. So in the coming video we're gonna do the analysis or modeling of the footing. The type of footing we're gonna do is isolated footing, strap footing, and column footing, and that all will depend upon the loading value. So thank you and have a nice day.